Today's lesson is over equations. Let's go over our last lesson. The number of pages read varies directly as the number of minutes. If you can read 20 pages in 45 minutes, how many pages can you read in 18 minutes? So the last lesson we talked about constant proportionality, about direct variation. What it means is you have a ratio and it's equivalent to another ratio. They all have the same ratio of k equal y over x. K stands for constant proportionality, y is for the y value of the ratio, and x is the x value of the ratio. So you can read 20 pages in 45 minutes. So 45 pages in 45 minutes in 20 pages. How many pages can you read in 18 minutes? You know, it's almost like a proportion. You know, a proportion is when you have two ratios that are equivalent. A couple ways you could do it. If you can break this down and show me a simplified ratio and build it back up. And I think that's what I'm going to do here in this one. So I'm going to simplify this ratio. What factor goes into 45 and 20? 5. I can divide both of these numbers by 5. That would be 9 over 4. Now, can I build it up from 9 minutes to 18 minutes? By 2. So 4 pages times 2 is 8 pages. So you can read 8 pages in 18 minutes, which is the same as 4 pages in 9 minutes, which is the same as 20 pages in 45 minutes. So this is constant proportionality. They all have a direct variation. That means they are all directly related to each other because they all have the same simplified ratio. And the constant proportionality is 9 over 4. Or another way to say it is you can read 4 pages in 9 minutes, or 9 minutes takes you 4 pages. So what is the difference between an expression and an equation? For the last couple of videos, you've been talking about expression this, expression that, algebraic expression. So let's see the differences. Can you find a difference? Let's see. Mr. Joe leaves the room to take a call from Tyra. You know, she calls me, stalks me. And you are in charge of continuing the lesson. How do you explain the difference between an algebraic expression and an equation to your classmates? So you are the teacher in charge. So instead of you being rowdy and throwing things at each other, you decided to get up in front of the class and teach for me. So 2 plus 7 is the expression. And on the other side, the equation says 2 plus 7 equals 5. This side says 2 groups of 3 plus 5. And this one, it says 2 groups of 3 plus 2 groups of 5. And that's going to eventually equal 6. I'm going to solve this. 6 plus 10 is 16. This one, 9x plus 4 plus 2x. And if I replace the x with a number, you get 26. And this one is 7 groups of x plus 1. If I replace that x with a 2, you get 7 groups of 3 equals 21. So what do you think the difference is? From what I can tell, these are missing equal signs. Equation has equal signs. So if I had to tell someone, I would tell them an equation has an equal sign. Think about it. Look, you see the word equal as part of the word. It's a prefix. So equal, equation. An expression is like a math phrase. We've been talking about it. It's a math phrase that contains numbers, operations, and variables or symbols or letters. But here it's the same thing. But actually in here you actually had to solve it. Another difference is in here you have to simplify to find the answer. And here you're now going to start solving it to find the answer. So can you solve 2 plus 7? It is 9. Can you solve 9x plus 4 plus 2x if you replace the x with, I don't know, a number? I think it was 2. Let's see, 9 times 2 is 18. Plus 18. 22 plus 2 groups of 2 is 4. 26, yes. And simplify, you put them together. So that's the difference. The main difference is an expression is a math phrase. An equation has an equal sign. It's this and that. You start with this and you end it up with that. What does the word is mean? You're going to see for the next few lessons, a couple of lessons, I'm going to keep saying the word is, or are. Like, what is 5 plus 6? Or 5 plus 6 is this. Is means equal. Like, for example, 3 plus 7 is 10. So it means 3 plus 7 is 10. And Paul is 2 inches taller than Mike. Do we know how tall is Mike? So what variable would you like to use for it? I'm going to say M is Mike's height. Do we know? So Paul is 2 inches taller than Mike. Again, Mike, we do not know his height, but we're going to add 2 to it. Is mean equal. So Paul is equal to, P stands for Paul's height. So Paul's height is 2 more than Mike's height. In a previous lesson, when we just did expression, all I care is could you write it as 2 plus m? It was said, the question was probably 2 inches taller than Mike. So 2 plus m. Now we are adding another component to it, whereas is. So what is 2 inches more than Mike? Paul is. So we're going to be learning this, I think, in the next YouTube video. So classify each of the following as an expression or an equation. So someone has an allowance of $12.50. That's it. Allowance of $12.50. Okay. That must be an expression. 23x plus 15 groups of 10 equals 610. So they must have replaced this x with a number. So it's equal to this. This is an equation. This is this and that. The product of 5 and a number. Do we know what number is? No. What variable or symbol would you like to use for that? N. So the product of 5 and a number is 10. So we saw this. What would N be? 2. So product of 5 and 2 is 10. So this is an equation. Now using the information, we're able to solve this. The area of a rectangle with a length of 8 inches and width of W inches is 72 square inches. So the length is 8. The width, we do not know, because it's like use the variable W, is 72 square inches. This must be an equation. But we could solve this if we want to. We can find the missing the variable. 8 groups of 9 is equal to 72 square inches. So equation has an equal sign. Equal sign, equal. They tell you what the answer is going to be. All right, so now we're going to do some guess and checks now. We're going to do these mentally. In subsequent lessons, we're actually going to teach you the mathematics using algebra tiles, through drawing, and through the mathematical process called inverse. If X represents the number of baseball cards in Craig's collection, do we know how many baseball cards he has? No, he has a baseball card. What could X minus 12 equals 7 represent? 7 will represent, so I guess he gave away 12, or someone took 12 from him. He sold 12. Now he only has 7 left. So what could X be? X minus 12 equals 7. Let's take a guess. I think, if I had to take a guess, I'll say, well, I know it has to be more than 12 because we ended up with 7. So I'll say 20. Is 20, question mark, take away 12 equals 7? No, 20 take away 12 is 8. So it must be 9. So it must be 19. x is equal to 19. So 19 take away 12 is 7. So guess and check. If x represents the number of seats on the school bus, what could 5x, 5 groups of x, equals 45? So in this equation, I would like to solve this. What should I replace x with? 5 groups of what? If I say 7, is 5 groups of 7 equal to 45? No, that's 35. Oh, I know. It's 5 groups of 9. So x equals 9. 5 groups of 9 is 45. If x represents the number of cups of sugar to make a pan of brownie, what could x be? So we do not know how many cups of sugar. So first, we had cups of sugar. It seemed like they divided into 2 portions. I guess they're making 2 batches of brownies. What could x be? If I say x is 16, question mark. Is 16 divided by 2 equals 7? No, 16 divided by 2 is 8. It's 14. So x equals 14. And last but not least, if x represents the temperature at 10 a.m., what could x plus 3 equals 68 represent? So the temperature is rising by 3. But do we know what time do we know what temperature it was at 10 a.m.? No. But can I find it by solving this equation? Yes, I can. So if I had to say x is, you know what, I'm going to try to guess this in one try shot. 65? Question mark? Yeah, it is 65 plus 3 is 68. So x equals 65 degrees. So let's try the next one. The McMean Junior High Athletic Booster Club is hosting a school dance to raise money for new basketball. 3 students sold tickets prior to the dance. We have Hale, Sam, and Wes. Hale sold twice as many tickets as Wes. Sam sold 10 more tickets than Hale. If W represents the number of tickets sold by Wes, write an equivalent expression. Again, expression does not have any equal sign. It's just an algebraic expression. It contains numbers, variable or symbol or letters, and operation. To show the number of tickets the 3 students sold together. So Wes sold tickets. It said use W, showing how many tickets he sold. He sold W tickets. We don't know how many tickets he sold. Hale or Haley sold twice as many tickets as Wes. Twice as many. So if Wes sold W tickets, she sold or he sold twice as many. That's 2W. Could you written it as 2 parentheses W? You could. 2 multiplication dot W? You can. Sam sold 10 more tickets than Hale. So what did Hale sell? Double what Wes sold. But Sam sold 10 more than twice what Wes sold, or 10 more of what Hale sold. Could I have written it as 2W plus 10? You could. Commutative property, back and forth and back. So now it says, what did they sell together? So we have Wes, we have Haley, and we have Sam. So together, you will add it all up. So what is Wes represented with? W plus. What is Haley represented as? 2W plus. What is Sam represented as? 10 plus 2W. And that is the algebraic expression. However, could we simplify this? Take what we learned from one of our lessons. We have a W. We have 2W, 2 more W's. We have 2 more W's here. How many W's do we have in all? We have 5W plus 10. You can keep it as the first statement, but I want to do less work because if I have to solve this, I would like just to do 5 groups of Wes, or 5 times what Wes sold plus 10 more. I don't want to sit here and figure out what Wes sold plus double what Wes sold plus 10 plus double what Wes sold. In the next one, there were 95 students. There were 95 students' tickets sold to the dance. Using the information in the problem above, write an equation that can be used to determine the number of tickets each student sold. So we know they sold 95 tickets. An equation is equal to something. It's this is equal to that. So now let's use our guess and check. 5 groups of what plus 10 equals 95? If I had to take a guess, I'll say 5 groups of 20. That's 100, right? Too much. Does not even make sense. 5 groups of 40. 5 groups of 40 is wait, stop. Why would I pick a number larger than 20? 5 groups of 50. 5 groups of 15. 5 groups of 15 is 75 plus 10 is 85. I'm getting close. I'm getting warmer. 5 groups of 18. 5 groups of 18 is 90 plus 10 is 100. No. 5 groups of 16. So 5 groups of 16 is 80 plus 10 is 95. So 5 groups of 16. So Wes, W equals 16. So that means Wes must have sold 16. What's 2 groups? Remember, Haley sold twice as many tickets as Wes. And Wes sold 16 tickets. What's twice of Wes? 32 tickets for Haley. And Sam sold 10 more tickets than Haley. Haley sold 32, so 10 more tickets will be 42. And that is our answer. So the main thing what we learned here is an expression is just an algebraic expression that contains numbers, a variable or symbol or letter with the operation. And that's all it is. An equation is equal to something. You start with this, and then you ended up with that. The way you can tell an equation is sometimes they use the, not sometimes, most of the time they use the word is. So blah, 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 blah is 24. So we know that is going to be an equation. And through it, you can find expressions, and then you can turn it into an equation and find missing, replace these variables or symbols with an actual number now. Because I know always kids are asking, x plus 5. What's x? What's x? Now we will be able to do x plus 5 equals 7. Now we're going to be able to find what x is. X equals 2. X is a missing number, a number that we do not know. Now we're going to be able to find that number.